One-shot colour cameras are a really efficient and convenient way of capturing colour data in your images. They have individual red, green and blue filters over each pixel on the sensor in a pattern called a Bayer matrix. So to see a colour image from your camera, you'll have to debayer it. Now our own software will automatically know the correct offsets for this. So if you're using Artemis Capture to take your images and Dawn to process them, this should all be done automatically for you. But if you're using other bits of astro imaging software, then you might have to manually debayer your images. And so we're going to go through and just show you how, and it's really not as bad as it sounds. So let's have a look at debayering in AstroArt. First of all, we want to load in our picture. We're going to use one we took earlier with an Atik 4120. You'll get a nice little preview here and the image header, so we can see this was a 5-minute exposure taken at -15 degrees. Now, this is a raw version of the image. It's black and white, and on it we can see this checkerboard pattern. It's a bit more pronounced if we zoom right in. That's the Bayer matrix. So I'm just going to make this a little bit smaller so we can see what we're doing. To debayer the image, we'll go into the colour menu, then CCD colour synthesis, and we get this little menu. This here is actually a representation of the Bayer matrix, and you can see if I change these offsets, the pattern changes. All our current colour cameras use an RGB sensor, so just check this is set to RGB. Then each of these offsets can only be 0 or 1, meaning there are only 4 combinations it could be. So we'll try 0, 0 first, and AstroArt opens it in another window. I'm going to open all 4 options so we can just have a look at them side by side. So I'll just select the raw image again and repeat it, this time putting in 0, 1. It's really important you go back to the raw image each time, otherwise you'll be debayering a debayered image and things will start to get a bit odd. We can see straight away that these two images look the same. They both have this magenta tone to them, and if we zoom right in, we can see this checkerboard pattern again. You'll always get 2 virtually identical images like this, and you can be certain that these aren't the right ones, so we can just get rid of those. That leaves us with this blue image, and with this greeny red image. We can probably say at this point which one's right, but we'll just go through a couple of things just to check. A really good trick is to have a look at your stars. If we zoom in, we can see that we've got lots of really blue stars. Now, plenty of blue stars exist, but they're really not this common. And if we have a look at our other image, you can see these stars are really yellow. If you've got these kinds of yellow stars, you've got the right setting. In other parts of the image, red is also a really good colour to aim for. If you're getting bits of red nebulosity and yellow stars, you've found the right one. So now we're ready to go on and process the image, align and combine it with other exposures, stretch the image and so on. Now, if you're thinking this still looks a little strange, it's really important to remember that you're doing this before you've done any other processing on your image, and all you have to think about at this stage is getting the right offsets, not really what the image actually looks like. Once stretched and stacked and aligned with other images, it will come into its own, but you have to debayer it before you do any of this. Another really popular piece of astro imaging software you can use for both capture and processing is MaximDL. First, we'll just load in the image we took earlier. Again, it's the raw version of the image, so if we go to the colour menu, then convert colour, we can debayer it in this little window. Here we get a little preview of the image and some settings we can change. Even from this, we can see a bit of red and a yellow star, so this is likely to be the right setting, but we'll go through the others just to check. So if we try 0, 0, we get this grid pattern, and we've got that magenta tone again, so it's not going to be that one. 0, 1 goes bright blue, so it's unlikely to be that. 1, 1 is our mirror of 0, 0, so it's not that either, meaning 1, 0 was our right setting, and we can press OK to apply it to the rest of the image. You might have noticed this is flipped from how it was in AstroArt. There isn't really a right way up in astrophotography, and different software packages handle orientation a bit differently. It doesn't really matter so long as your images are all consistent within themselves when you take them, and that you debayer them before turning anything around. So we'll just have a quick look at Artemis Capture. Capture's really nice in that it can show you a colour image as you're taking your exposures, and it'll automatically know the right Bayer offsets, so you can get a really good idea of what your final image might look like from the moment you start capturing your subs. If you want, you can also choose to see the raw data by going to this colour menu and selecting raw. You can also choose luminance, which will remove the matrix and show you a synthesized monochrome version of the image. What you have to remember in Capture is that anything we do is for display only, and what we save will be from the raw camera data. So if we've got all our captures and we want to go and process them, we can always use Dawn. Here you can do all sorts of things like aligning, combining, dark frame correction, but what we're interested in here is debayering. Just drag and drop this debayer option into the workflow, then right-click the input files and load your image. If we then click on the debayer folder, we can see the debayered version of our image. Again, the really nice thing about Dawn is that if you've taken your image in Artemis Capture, Dawn will automatically know the correct offsets. But if you did want to change them for any reason, you can just right-click on this debayer function, and here they are. Once your image is debayed, you can just right-click anywhere on it and save displayed image. This gives you a choice of BMP, JPEG or TIFF format, so you can then go on to process your photos in other programs like Photoshop. Dawn also comes with a number of templates you can get by right-clicking in the workflow and selecting Load Template. There's a little description of each, but just to give you an example, this one allows you to load in your flats, darks and lights, which will then be dark corrected, flat fielded, debayered, aligned and combined. Obviously there are loads of other software packages available, but the same basic principle stays the same. You'll always have a choice of 4 offsets, and it's just a case of finding the right one. And once you've found it, write it down. It won't change for that piece of software. Now, the only thing that we haven't mentioned that we probably should is using an IR blocking filter on a colour camera. Now, differences in focus between your infrared and your visible spectrum can lead to things like star halos, and because all 3 channels are sensitive to it, it can also lead your images to become a bit desaturated. Now, we don't include them as standard because they do block a little bit of signal and not everyone wants to use them, so we design our cameras to be as flexible as possible. But if you are having problems with desaturation, it might be something that you want to consider. But apart from that, I think you're all set, so happy imaging.